good morning. I'm Sylvia. Okay, can you hear me? Yeah, perfect. So I'm Sylvia. Thank you. First of all, I'd like to thank you to allow me to present to show this preliminary study, which comes from my master thesis. So let me introduce you to the temporal variability in whale shark present in South Aryan marine protected area in the Maldives. So, as a background, in Maldives, whale shark as always have an important socioeconomic value, okay? In the past as a target species in fishery, and nowadays is the main attraction for ecotourism. In 1995, the Maldives was one of the first countries that banned the hunting. First of all, for the low monetary value of the fishery, but also in order to preserve its stock and favor tuna fishery and ecotourism activities. In 2009, three marine protected areas were established in order to protect the biodiversity and the megafauna. And in the Ari Atoll on the west of the archipelago is one of the biggest atolls there. The SAMPA, so the South Ari Marine Protected Area, were established and is one of the biggest. And it was selected mainly for the presence of the whale shark there. It extends from Digura to Rangari Island, and it comprises 1 kilometer seaward buffer zone from the crest of the reef for a total area of 42 square kilometers. According to the literature here, is present a year-round aggregation, mostly composed by immature males. Okay, so the aims of this preliminary work is define the favorable weather or environmental condition in order to analyze the shark presence and its temporal variability there. This can allow us to delineate potential drivers in change. Okay. Okay, all this work was possible thanks the crucial effort of the Maldives Whale Shark Research Program, the only long-term organization that carries out research on these iconic but also vulnerable species in Maldives. They were born in 2006, and since 2012 they focalized their effort on the marine protected area in order to study the year-round presence of the whale sharks and also the influence and effects of the ecotourism on it. So, data are collected daily from 9 to 4 p.m. more or less on board of a wooden hull Donny, a local boat, and the research schedule and the area patrol depend on the weather condition. From the upper deck of the Donny, we searched for the dark silhouette of the shark, and after spotted it, we started the encounter and the procedure of approach. So data are collected both from the boat and from the water. For each encounter, we took 4 types of data: logistics, so for example, date, time, coordinate; biological, so everything about the animal, the individual, so the sex, the length, the ID in some cases; anthropogenic data, so everything about the ecotourism activity during the encounter; and in the end, environmental data. With environmental data, we mean depth of the reef, sea surface temperature, current direction and strength, visibility, wind speed and direction, and cloud cover. And for this work, we took into account wind speed and cloud cover. Okay, after that, we compute SPUE, so science per unit effort, as a number of encounter per survey trip under favorable environmental condition. And we did this work in order to control and to reduce the effort bias. So we define this favorable environmental condition, FEC, as a wind speed equal or less of 3 Beaufort and cloud cover, clear or partially covered sky. Due to the heterogeneity of the effort, we decided to select as a time period, as our period study, the years between 2030 and 2070. Okay. As a result, under this setting, okay, we can see that the encounters per year, they are quite homogeneous. We can see that in 2040, we have less encounters. Contrary, in 2015, we have the maximum number of the scientists. After that analysis, we develop univariate general linear model in order to test, to analyze the variability on 2 different scales, years and months. So, talking about the year variability, we can see that during our period study, there isn't significant difference in SPUE. But contrary, this is an interesting thing, if we take into consideration monthly year basis data, we can see that, so the differences between the month of the same year and the month of the different years, okay, we can see that there is significant differences. It's quite interesting. So, in the end, as a discussion, as a lesson learned, we didn't observe any temporal specific defined pattern in the shark presence there. So we can say that there is no seasonality in this area. And at this point, 2 main questions arise. First, is the sampa always attractive for sharks? And second, what is the meaning of the variability observed? So, it's a preliminary study. We started to check our available environmental parameters, and we started with the sea surface temperature, because during each encounters we measure sea surface temperature in situ. And an interesting thing, we can see that as the presence of the whale shark change in the months of the same years and in the different years, we can see that also the temperature show significant differences in years and months. It could be a suggestion to a potential influence of this environmental factor parameter on the shark use of the marine protected area. Okay, and here you can see. So, as a future work, we want to correlate the sea surface temperature pattern with the CPE in order to understand the potential influence of this parameter on the shark present. Then we want to increase our analysis on our model, and we want to identify other potential drivers of change in species habitat use, for example, pressure of anthropogenic activities, other environmental parameters, or also bathymetry, okay? And in the end, we want to understand the role of these potential factors in the species presence and use of the sampa, so of the South Area Marine Protected Area, not only temporary, but also spatially. So, thank you very much for your time and for your attention.
Thank you.
Thank you
very
so much.
Question or comment?
Yes, one question.
Yeah?
Do you relate the presence of whale shark only about sea surface temperature or also other environmental parameters?
Okay, it's a primary study. For this moment, we want to try to correlate this parameter, and so let's see if there is any correlation with the present. But in the future, we want also, if will be possible, understand if there is any correlation with the currents, and so the differences in the water of the temperature in the water column. Thank you very much for your question.
Okay, thank you very
Okay,
much.
thank you. Thank you.
The next speaker is Gaël Legoisier from France. Mercury isotopes as traces of ecology and metabolism in two sympatric shark species. Please.
So, good morning, everybody. So, my name is Gaël Lecroisier, and I will present you of my current postdoc work in the JET laboratory in Toulouse, France. So, about the use of mercury isotopes as tracers of the ecology and metabolisms in two co-occurring shark species. So first, a little bit of context. As you may know, bioaccumulation corresponds to the accumulation of contaminant over time, while biomagnification corresponds to the increase of the contaminant concentration with the trophic level. So as you know, top predators are characterized by a long lifespan and a high trophic level, so they are particularly prone to high contaminant concentrations. This is the case for methyl mercury. You can see in this study of various shark species in South Africa that the mercury concentrations are quite high, so mostly above 1 microgram per kilogram white weight for most of the species. And if we look at the two species I'm studying here, the bull shark and the tiger shark, you can see that the mercury concentration are similar. So we know that the two species are co-occurring in the same ecosystems, but they can show different habitat use. For example, the bull shark can show coastal residency and incursions in fresh water, while tiger sharks are more are able to perform large offshore movements and also to dive. So we also know that they are co-occurring, but they are different regarding their trophic ecology. Bull sharks can show a high individual specialization, as well as a strong dependence of coastal resources, while tiger sharks are supposed to be more generalist predators, able to feed both on coastal and pelagic prey. So now a little bit of words about the tools I'm using, the mercury isotopes. So we know that mercury isotopes are submitted to mass-independent fractionation of the odd isotopes, so called the MIF, characterized by the capital delta 199. And this fractionation only occurs under the influence of solar radiations. We know that there is a MIF gradient along the water column with a decrease in MIF values with an increase of the depth. You can see in this study from Hawaii that different fish species show a decrease in MIF values alongside an increase of the median depth of occurrence. So MIF is a potential good proxy of the foraging depths for marine species. We also know that there is no mass-independent fractionation during trophic interaction. In this case study in the Faroe Islands, the MIF values for the whaler population were similar to their diet, so the pilot whale. So here we can use this this tool as a good trophic tracer, thanks to the absence of fractionation. Secondly, mercury isotopes also show mass-dependent fractionation of even isotopes, so-called MDF, characterized by the delta 202. So this is the classical isotopic fractionation. So this is due to physicochemical processes like MIF, but also it occurs during biological processes such as methylation and demethylation of mercury, such as observed in mammals. For example, you can see for this terrestrial mammal, the delta 202 value for the assimilated methylmercury will be submitted to demethylation, resulting in inorganic mercury, showing a decrease in delta 202 values, while the remaining methylmercury will show an increase in the delta 202 values. So in this context, the objective of this study were first to trace the foraging depths of sharks using so the MIF values alongside the water column, and also characterize the diet. And secondly, to explore the use of the even isotope fractionation, so MDF, to evaluate mercury metabolization by shark species. So the sampling site was the Réunion Island in the southwest of the Indian Ocean. So this is a French volcanic island. We collected muscle samples from 20 bull sharks and 20 tiger sharks, as well as muscle samples from various potential prey species representative of the different habitats within the shark ecosystem. So we collected fish from the coastal habitat, from the shelf of the island, epipelagic, mesopelagic fish. So here are the results about the MIF, mass-independent fractionation. So for the different telehost fish species, you can see here the different species we analyzed. And we can see that there is a large range in the MIF values for the different fish species according to the habitats. And here are the values for the bull sharks. So the horizontal line represents the median value, the mean value, sorry, and the orange bar, the standard deviation. And you can see that the MIF values for the bull sharks are similar to coastal species. So allowing to conclude that the coastal habitat is the main foraging habitat for bull sharks that are mostly feeding in coastal prey. And here are the values for the tiger sharks, similar to the values of the prey species inhabiting the shelf. So we can again conclude that this kind of prey is the main mercury sources and the main foraging habitat for tiger sharks. So if we compare both species, you can see that tiger sharks show lower values compared to bull sharks. And this is likely due, like I said, to the difference in the foraging habitat between the two sharks, with tiger sharks foraging deeper. Now the results about the mass-dependent fractionation of the even isotopes. So we found a really large shift in the delta 202 values for both species between the sharks, the predator, and the potential prey, like around 1.4 per mil for the bull sharks and more than 1 also for the tiger shark. So it was really surprising because from experimental studies, we previously known that there is basically no fractionation or very little between the diet and the consumer for telehost fish. And here the values for the bull sharks and the tiger sharks are really high. You can see that they can reach more than 2 per mil for the bull sharks. And these MDF values are more similar to what we observe in marine mammals that are able to demethylate mercury. So it strongly suggests that mercury demethylation occurs in sharks, and this is not the case for telehost fish. We also found an increase in the delta 2 values with the length of the sharks for both species. You can see the results for the bull sharks. So it suggests an increase in demethylation capacities with age, as we know that MDF can be a proxy for demethylation. And it's also similar to what has been previously observed in marine mammals. So we found the same patterns, suggesting, as for marine mammals, an increase in demethylation capacities with age. So to conclude, we successfully used the MIF gradient with depth to characterize the vertical and the foraging habitats of the two shark species. It can be an interesting tool to complement tracking studies, for example, that can be expensive. And we also use the absence of MIF during trophic transfer to characterize the diet composition of the sharks. So the combination of these two results, for example here, since there is no fractionation between prey and predator, it can be a really powerful tool compared, for example, to carbon and nitrogen isotopes, for which we generally don't really know the fractionation between prey and predator. And for example, this tool could be really useful for, I don't know, for determine if, for example, white sharks are feeding on mesopelagic prey within the cafe, or if there is competition or trophic interaction between sharks and tunas, for example. And finally, we show for the first time using MDF as a proxy of metabolic processes that mercury demethylation may occur in shark species, which is really different compared to what has been previously shown for telehost fish species. Thank you very much, and if you have questions.
Thank you, Gal. Any questions? One question, sir. Francesco? Microphone. Sorry.
I was wondering about your intervals, the confidence intervals that you had there. You say that it's one standard deviation.
Yeah.
Would you say that makes the two species statistically significant, different one another?
Yeah, they are statistically different, yeah.
But if you take two standard deviations from that line, they overlap quite a lot. I mean, one standard deviation is only 63% of the around your mean.
Yeah.
But if you take a confidence interval, you should take a 95% of your around your mean.
Yeah.
And that would make them quite overlapping. And so I was looking at your increase in size, and you see that.
That's not for.
This one.
Yeah, that's not the same.
That's a lot of range in there. And then I'm wondering whether these differences you're seeing there is mainly due to the size of the animals.
Yeah, so the two hypotheses is that there is, so first an increase, like in mammals, of the demethylation capacities with the age of the sharks. But it's also correlated to the mercury concentration that increase over time. So the bigger the sharks are, the higher the mercury concentration will be, and the most they will have to demethylate mercury to maintain a concentration which is not too toxic for them. Okay. But this is delta 202, representing the metabolization. And this is capital delta 199. So here it's only describing the foraging depths and also the difference in prey. So, but the two species are statistically different.
Okay.
Yeah.
Thank you.
Okay, thank you. There is no time for more questions. Thank you again, Gael. Next speaker, Brit Finucci.